So, welcome to another lesson. This is Pure 2, Chapter 4.3. The previous two lessons, we look at cubic graphs and quadratic graphs, sketching them. And this time, we're not looking into the, I think, quintic graph, maybe x to the power 5. No. So, up to the syllabus only asks us to learn all the way up to quadratic graph, x to the power 4. The next type of graph is a reciprocal graph. Now, before we start, let's have a look in the notes. Why does a fraction with denominator as 0 in a calculator gives maths error? So when you put 4 divided by 0, you get maths error. 10 divided by 0, maths error. The reason, because technically they are, we call them undefined. Now, if you want to listen, okay, why is undefined, okay, I can explain it, but if you're not interested, just skip forward a little bit, okay? When you're dividing means you're separating into packets. Imagine, okay, so imagine you've got 8 chocolates in it, or 8 chocolate coins in here, okay? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 chocolate coins. Now you want to put them into bags of 2. So when you put them into bags of 2, or does it not look like a pig nose 2? Anyway, divide into packs of 2, then you get 4 because 8 divided by 2, 8 coins divided into packs of 2 equals 4. So 4 packs. Now, but when you divide by 0, means you are putting into a pack of 0. So technically, that doesn't make sense logically, because when you're dividing something, you have to put them in groups, but you can't have a groups of 0, if that makes sense. So you have 8 coins, but you can't put them into a group of 0. So therefore, it's called undefined. So technically speaking, we call it tends to infinity. It does not equal to infinity, but it tends to infinity. That's the mathematical definition. Anyway, let's come back to this. So to present this feature on the graph, when we have maths error, so how do we present? We use what we call asymptotes. So asymptotes. So now, one classical example that you've learned so far in GCSE is the graph of 10x. So e.g., if you've got y equals 10x graph, okay? Do you remember how to draw a 10x graph? Okay, so in GCSE, you've learned how to draw 10x graph like this, right? That's 90 degree, and then go from here to here, and that's 270 degree, and this is 180 degree, and then this is 360 degree. That's the 10x graph. Now, if in A level, if we go in the previous, go beyond 0 degree, go to the left beyond 0, we have negative degree. So if you continue to draw the graph like this, basically, we call this negative 90 degree. Actually, negative 90 degree. And then we can go, oops, and then we can continue the same. Negative 180. This is negative 270. And then you have the negative 360 degree in here. Sorry about the drawing. Anyway, it's not that important because you learn it properly again in chapter 9, I think. Trigonometry. Yeah. Okay. So what's more important is this one are these little dotted lines. These dotted lines are called asymptotes. In this case, the equation of the asymptotes in this case is x equal 90 degree, 270 degree. Actually, it's plus and minus. So x equals to minus 90 degree or minus 270 degree. Ultimately, we can rewrite them a bit neater to x equals plus and minus 90 degree and plus and minus 270 degree. Okay, right. So again, we'll learn all of this again later on. So, but in here, the main keyword is about asymptotes. So what are asymptotes again? Asymptotes are a line, an invisible line. So this is not the technical definition, but it's something for you to remember. It's a dotted line where the graph approaches but never touches. So it's like an invisible line, invisible wall, where we get closer and closer, we're edging closer and closer, but it never touches it. Okay, right? So reciprocal graphs. So the couple of reciprocal graphs we need to know is the first one. There are 4 prototypes that you need to know. Okay, you probably have seen this in GCSE. The first one is y equals k over x. Okay, so k over x. Well, what does it look like? Okay, so let me x and y. Let me copy and paste this because we'll need this for later for next one. So y equals k over x. Imagine y equals 1 over x, 2 over x. Do you remember what the graph look like? It looks like this. And this. Okay. So we can see we start from here. Oh, actually, we start from here and here. Oh, it should never be touching both axes. Okay, so the asymptotes are, so we've got the asymptotes at x equals 0 and y equals 0 because you can see here both curves are reaching the y-axis, but they're not touching it. Same for the x-axis. We can see, okay, so these are asymptotes, all right? X equals 0, y equals 0. Now, that's one graph. Now, what about if k, so k is a constant, so if k equals 1, it looks like this. What about k equals 2, 3, and 4? I'll show you the graph. Now, so that's the y equals 1 over x graph. We've seen this. Next, what happens if 1 becomes a 3? So y equals 3 over x. You can see we are getting further stretched out by 0. We're getting further away from 0, but the shape looks the same. What about y equals 10x? It gets further away from 0, but again, the shape remains the same. Okay, we're both in the positive x-axis and both in the positive negative x and y-axis quadrant. Y equals 100, it's the same. You can see the shape of the graph remains the same. Now, it looks like it's touching the x-axis, but when you zoom in a lot more, you will see, okay, if we zoom in a lot more, you'll see they're never touching it, okay? So it doesn't matter how far you drag it, you'll never reach the x-axis, okay? So that's how we can draw the graphs. All right, so if you want to put them in, you can. So let's say this is y, this is when y equals 1 over x. If you want to draw a couple of them, you can. So this is maybe, actually, this may be y equals to 10 over x. So just to give you a bit of idea. Okay, next one. Y equals negative k over x. Okay, y equals negative k over x. So the difference is we have one in here and one in there. Okay, asymptotes still the same. X equals 0, y equals 0. You can put the asymptote in there if you prefer, but we know the asymptotes are going to be the same. Okay, next one. Y equals k over x squared. So k over x squared. X squared means when you put whatever x value you put in there, the outcome is going to be positive. So both of them are up, positive on the positive y side. Now, mathematically speaking, because imagine you put a negative value of x in there. When you put a negative value, you square it, it becomes positive. So the whole thing becomes positive. Therefore, this graph is always on a positive y axis. All right. And the last but not least, y equals negative k over x squared. You could guess how it looks like. It's going to be both of them. It's going to be on the negative side. Okay. Right. So these are graphs. Nothing else you have to do really, just apart from remembering, really. Okay. Unlike the quadratic graph and cubic graphs, these ones you just have to remember it. So practice question 1. Okay. Sketch a following graphs on different axes. Okay. See if you can match out which one is which from the previous prototypes. Okay. Pause the video, have a go at the question. Okay. Try to draw the graphs. When you're ready for the answer, you can press play. This are the answers. So what about numbers? No, we don't need any numbers because they're not crossing any X or Y axes. Okay, so there are no numbers. Okay, it is what it is. Right. So you can see they should be symmetrical, but again, my art skill is only so limited that I could try to make them symmetrical, but then they don't look symmetrical, but they should be symmetrical. So try your best, but if it's not, I will still get full marks if I do this in exam because we know it's a sketch. Right, next. Oh, that's the end of 4.3.